seismic analysis of dams and landslides. For the last 2 days, you might have, listened to the talks related to buildings. I think yesterday, Professor Amjad Masood talked about masonry structures. Then you might have listened to Professor Dubey regarding the lessons that we have learned from the past earthquakes. So he must have targeted on the buildings, I suppose. Or he also talked about some other structures. Did he talk about other structures or only just the multi-storied buildings? Multi-storied buildings. And then you must have gone through the ductility requirements which are required for the earthquake resistant design. See, apart from the multi-storied buildings, other important structures that play a very important role in civil engineering are the hydraulic structures. And among the hydraulic structures, then the very first name that comes into mind in terms of the hydraulic structures are the dams. So today I will be talking more about the seismic analysis of the dams. And when we talk about dams, landslides are one very important factor which comes into mind because until and unless you have the reservoir stable, the dam stability is less important. So first I will be talking about dams. Now, as you have learned about what are the lessons that we learned from the past earthquakes with respect to buildings, I'll first go through some case studies. Then what are the lessons that we learned from the past history in terms of the static as well as the seismic analysis in terms of dam studies. Because this is one area which in civil engineering is lacking behind. You know, IS 1893 came out in 2002 and then now it has also been revised in 2016. So which part of that has been revised is only part 1. And that part 1 is with respect to the buildings. But the part 5 was not out in 2002 and still in 2017 we do not have the draft of IS 1893 part 5 with respect to dams ready. Because the knowledge in India that we are having in terms of the hydraulic structures is lacking behind. Okay. So when we are talking about dams, then what questions we start off with? We start off with that whether the foundation is stable, whether the foundation is stable in terms of water tightness, whether the storage area where the water is being stored is stable, and then whether the landslides which are there, with the rock area which is there all along the side of the reservoir, is that stable? So why do we ask these questions? We will answer them with the help of the case studies of the 5 dams. I'll also show you the failure of one of the Teton dam and how the dam fails. And when a dam fails is much more damaging rather than when a building fails. Because the amount of destruction, the devastation, the loss of the life, the loss of the property that we have in terms of the failure of the dam is much more than that we have in terms of buildings. So I start off with the St. Francis Dam. So this was a concrete gravity dam. It was built in, it took 3 years to build it. 1926 it was commissioned and in 1928 it failed. Such a huge structure which was built with such an enormous amount of the effort and that, failed. Why did it fail? See, this is, I think you can all recognize. This is the dam structure that we have. Okay. So this was what was there in 1926-27. And then when it failed, this was what was left. A huge structure of the concrete which was there, before, and when it failed off, everything was washed off, only this portion was left. And it killed more than 420 people. What was the reasons behind it? See, as a civil engineer, we always study, we have one course, engineering geology. So the geology is with respect to what? The geology is with respect to the rocks. So not only the concrete portion we as a civil engineer have to focus, we also have to focus on the geology of the rocks which is there. So what was there was, on the one side there was Vesper conglomerate and on the other side it was schist. And this type of the rock was that when it came in contact with water, it was susceptible to disintegrate and flow like, what flows in the liquefaction. See this. And what was there was a major fault which was there, which was not studied. This was the entire structure of the dam. This was what was left. You have one type of the rock on this side, another type of the rock on this side, and then you have a fault. What is a fault? Fault is basically a discontinuity. Okay, so but it is not very small, it is broader and it has something inside it and it is all along. So if you have a fault and some vibration is going to occur, this is going to divide this part of the earth to one side and this part of the earth's crust to the other side. It has that potential. It is not shallow, it is very deep. See, so what happened? And this is what we have today. Okay, so what was the reasons of the failure was, there were two types of the rock which were separated by a fault plane. Okay, so there was a sharp contact which was there between the two types of the rocks. So there was hydraulic piping, and another important thing which is very common in India or any other countries, that because of politics and some other things, we design any structure for some height, we increase that because the requirement has increased. Similar was the case in this case of dam, that its height was increased 20 feet without doing anything, without studying about the foundation, without studying about any other thing. So what happened was, there was also, when there is a fault, the water is going to be there, the water is going to penetrate, there is going to be the hydraulic pressure is going to be there, and when water is going to seep into the rock and that rock is susceptible to disintegrate, what's going to happen? Something which was expected and it happened. Okay. So what we learn from this case study, that the geology is very important. Then the Malpasat dam, another arch dam. This was an arch dam. So it was in France. It was a double arch dam. It failed in 1959, killed 459 people. A failure of the dam. And why did it fail? You see. So this is the river, because I think you all understand that the dam is built across a river to store the water behind it. Okay. So this was the dam axis. It was an arch dam. So I'll show you this. That will be more clearer. Okay. So this was the dam. This was the gneiss type of the rock. There was a fault. This was a zone of permeability, increased permeability. And here you have a zone of reduced permeability. Then what's going to happen?
सर आपका पॉइंट चल रहा है ना?
सर वो ज़्यादा विजिबल नहीं है यहाँ पे, पर्पल कलर का है। मेरा अपने वाला नहीं चल रहा है, शायद लग नहीं रहा है इसका, मैं ये भी लेके आई थी, इसका चल नहीं रहा है।
ओके कोई बात नहीं।
So what happened? There was a region of increased permeability. There was a region of decreased permeability. Then what do you think is going to happen? Uplift pressure. So you have the resultant force in that direction. When you have the resultant force in that direction, you already have this is the discontinuity which is there. It is not allowing something to move here. This is the watertight area that is there. This is going to act like this. What's going to happen? That wedge is going to form there, and the wedge failure is bound to happen. And that was what happened here. And this dam failed. Okay. So this is just the 3D mechanism of that. So you have the region of increased permeability, you have the region of decreased permeability, you have a watertight fault leading to the uplift pressure and leading to the failure of this structure. Then is the Teton dam. We've talked about the arch dam, we have talked about the concrete dams basically. Now, this is an embankment dam. You understand embankment dam? Something that's made up of soil. Okay, different types of soil. So this was a 300 feet high earth dam and it failed in 1976 after being filled for the first time. The reservoir was filled for the first time. Just think of a structure which is built, such a huge structure, and a huge structure does not come out in days. It takes years to come out. And when you fill up the reservoir and in the first go it is gone. Okay, so why did it gone? The liability on this depends upon us as a civil engineer. Okay, no seismic activity also. It is just because of the geology of the type. So I'll show you. See, this is the sequence of the failure that took place. So this you can see the clear water springs from the joints in the rocks. So there was water that was seeping out. 305 feet that you see is the embankment dam. Okay. Then from this left abutment there was muddy seepage observed at the right abutment that was there. You can just see the time. See, that is June 3. June 5. More muddy water was coming out. So indication was there. Okay. June 5 at 10:30 a.m. you have a hole in your embankment dam. Okay. Then 15 minutes later, that hole continued to increase because the seepage of the water was there, the hydraulic uplift pressure was so much, and that hole increased 30 minutes later on the same day. So, in minutes, things happen. And then that hole that reached to the crest of the dam, and the entire dam was gone. Okay, so I'll show you a movie of this. So how this dam it's going to play here. Do we have the volume here? The volume is going to be there or not? No. So then I think you'll not be able to, because there's a voice, behind it. See, this is just saying that there was a hole here in the embankment dam, and with time that hole increased. Okay. So because the volume is not. Huh?
Large.
वो बड़ी होगी तो blurred हो जाएगी सर. Because this is the. So वो दिखेगा नहीं इतना अच्छा, वो वॉल्यूम भी नहीं है, वो सारा पूरा वीडियो था इसमें कि कैसे वो होल बना, होल बनते बनते वो बड़ा होता गया तो कैसे वो क्रेस्ट तक पहुंचा, फिर पूरा पानी and then the entire water, and that embankment dam was. Okay, so we continue further then. Okay, so what was the reasons for the failure? The reasons of the failure was the piping action due to the seepage of the water. Then the Shishkan dam, the dam which failed because of the seismic activity. It was after the Chichi earthquake, this dam failed. So it was a 25-meter gated spillway structure. It was located downstream of the 5 dams and it failed after the Chichi earthquake. So what an earthquake can do, we all know. We already are familiar with it. So this is the hydraulic spillway structure that you have. Okay, so this is the spillway structure that you have. This is the reservoir and this is the downstream side. So upstream side we say, जहाँ पानी खड़ा करते हैं, reservoir side. Downstream side is where the spillway water is there. So you have the upstream, you have the downstream side. So what happened in this was that there was a gated spillway structure. The dam portion increased by 9.25 meters. know, that is a potential. You see, this is a fault. If you have two sides, you have the fault here. So if this fault is there, you have the dam all along it, and when the earthquake is going to do, it will happen, this portion increased. The height of this portion increased by 9.2 meters. So what's going to happen? The entire dam structure that you have is going to fail. So what was the reasons behind it? Again, the geology of the rock structures that we have. There was a major fault that was there, which was passing through the dam structure. So you were having this spillway structure, and perpendicular to this there was a fault. And when the earthquake came, it became active. There was a large significant amount of the movement. As a portion, one portion was lifted up. Okay. So this was the location of the Chelumpi fault that is given. Then the Baldwin Hills Dam, another case study of a dam. You know, this dam suddenly failed following the displacement in the foundation. So though the failure was not attributed to the earthquake, but the movement was concentrated where? The movement was concentrated at a fault. A fault, a major discontinuity. Okay. So see, again the sequence of failure. At 11:15 a.m. an unusual sound of running water was detected in the spillway discharge pipe. So the people, everybody moved to, lock that so that that can be blocked. At 1 p.m. muddy water was discovered emerging downstream. So downstream side you have the muddy water that's coming out. That means the water and the soil is moving out. Okay. At 2:20, the receding of the water level revealed 0.9 meter wide rupture in the lining of the dam. At 3:30, a huge gush of water blew mud and the crest of the dam, and everything was washed off. So what was it? It was the result of the long-term stresses that were built up in the foundation. Okay. So the evidences indicate that the movement which triggered the reservoir could be associated with the land subsidence. Now, ये upliftment नहीं है. It was the subsidence. So what are the variety of things that we see? So what can we conclude from this portion of the topic about the case studies? So what important is that the geology of the dam foundation, not only concrete is important to us as a civil engineer. There are other things which are related to that. If you want to keep your concrete stable, you have to study the geology on which that concrete is there. Okay. So then dam to rock interface. The dam is a concrete portion. Rock is there. So what's happening in the concrete to the rock interface? What is happening to the concrete interface? What is happening to the rock interface is very important. Because all together is going to help us in understand whether our hydraulic structure is stable or not. So the geological parameters of the rock mass is the permeability, shear resistance, deformability of the rock. So thorough knowledge of the rock structure, the types of the rocks, the type of the weakness planes such as faults. So the thorough dam and structure needs to be analyzed in terms of the discontinuity. So this is what I am going to focus now in my future talk, that how we can understand these discontinuities and which type of analytical softwares do we have with us which can help us in understanding these types of structures. So, as it has been very well written by Milken, for every complex problem there is a solution. We cannot say that there is a problem that does not have a solution. For every complex problem you have a solution that is simple, neat, and it can be wrong too. So in the field of mechanical engineering, it is said that models can be built, validated and used with conviction. But when we talk about the structure-rock interaction, one seldom knows about what the rock mass is. We have to take certain initial things, we have to assume certain things, and then we have to model it, and then we have to study it. So taking these bases, there is a then we have to, so this is the numerical methods of slope as well as the dams. So you have continuum modeling. So can you give me one analysis software which deals with the continuum mechanics? Something, see, this is the wall that you have. If I want to model this entire wall, I can model it as a block. One block. That we normally do in our structure analysis. What are we doing analysis? We are just taking up the columns, we are taking up the beams, and we are doing the modeling. Okay, if you want to model the shear wall, you take this wall as a whole. But is this wall one unit? No. It's made up of bricks. That bricks are separated by the mortar. Each and every element is single entity. So when you are talking about the continuum mechanics, we model this entire wall as one. When you are talking about the discontinuum modeling, you model this wall brick by brick. And when we are talking about the hybrid coupled, that means you model some portion as continuum, you model some portion as discontinuum, and then you study the interaction studies. Okay, so I am not talking about continuum is FEM, finite element analysis that you do. So every one of us have learnt about the continuum mechanics. Since you see, I think all of you are MTech students, you all have done MTech, all are faculty but have done MTech. You all are the future people who have to take these topics for the research. Until and unless we take up any topic which is of importance to it, and it can be beneficial to the Bureau of Indian Standards, that is our contribution towards our engineering field. So you people have to find out, we do not have IS 1893 part 5 with us. We do not have a draft. So what contribution we people can do towards making it?